Hello everyone, welcome to another episode from Chedexcel. Today we are going to talk about calculations based on limit in reagent. So last class we did the calculations based on normal chemical reactions, we balanced them and we did the reactions. Today we are going to look at how we can do chemical calculation using the limit in reagent. Now, the limiting reagents are actually obtained when you are given the data to both reactants. Let us say you have two reactants and you are given the data for both reactants. So, by knowing the amount of each substance, we can predict which one is the limiting reagent. We have to use the molar ratio, and using the molar ratio only we can decide which one is the limiting reagent. Just using the mass or just using the amount in moles, you can't decide which one is the limiting reagent. For example, let us say you are going to make a chicken gravy or chicken curry and you have 1 kilo of chicken and 500 gram of salt. Knowing that 500 gram is less than 1 kilo, you can't say salt is the limiting reagent. We all know if you add 500 gram of salt to 1 kilo of chicken, you can't eat that. Because to make 1 kilo of chicken, you might need very little amount of salt. You don't need 500 grams. So, mass wise 500 gram is the limiting part, the smaller value, but it is not the limiting reagent. That 1 kilo of chicken is the limiting reagent in that particular case. Same for the chemical reaction as well. Knowing the amount, we can't exactly say that substance is the limiting reagent, because you have to do it with a calculation and you have to find it using the molar ratio. So, we will see how we can find that one, and we will see to do some past paper questions according to the limiting reagent calculation. Okay, in limiting reagent calculations, we have to follow a few steps. The first step is find the amount in moles. That is very important, using the data or using the given data for each reactant. That is a very important and the very first step we do. We find the amount for the both reactant using the given data. Second one is use molar ratio to find out the limiting reagent. Then you have to find use the molar ratio to find out the limiting reagent, and last step is do the calculation using the limiting reagent. So, those are the three steps we have to follow. You have to find the amount of each reactant using the given data. Then you have to use a molar ratio to find out which one is the limiting reagent, and then we have to do the calculation using the limiting reagent. So, we will see how to do that with a simple example, right. So, we will do a simple example. So, 2 gram of magnesium is added into 150 cubic centimeter of 0.8 mole per decimeter cube HCl solution. Question is, what is the volume of hydrogen produced at room temperature and pressure? Right. The reaction is this, magnesium reacts with HCl to produce magnesium chloride and hydrogen. So, this is the chemical reaction. So, this is the limiting reagent calculation, and this is normally come for the MCQs. You are given the mass of magnesium and you are given the volume and the concentration of HCl, which means you are given the data for both. So, we have to find out which one is the limiting reagent, because hydrogen is produced according to the limiting reagent. So, first step is what? Find the amount of each. So, I am finding the amount of magnesium, mass or molar mass, 2 gram divided by 24.3, right. So, 2 divided by 24.3, 0.082. Okay, we'll keep like this, 0.082 moles. Then amount of HCl, concentration into volume, amount equals concentration to volume. Concentration is 0.8, volume is 150. So 150 divided by 1000, because you have to convert into cubic decimeter. So 0.8 into 150, 0.12, right. Now look at this, the amount wise HCl is higher than magnesium. From that onwards you can't say magnesium is the limiting reagent. It's like the chicken and the salt case. You have higher amount of HCl, but magnesium is less than that. But we have to find, using the molar ratio, whether magnesium is actually the limiting reagent. So how do you do that? You have to use the molar ratio thing, right? So you have to use the molar ratio thing. So what you do is this, amount of HCl for 0.082 magnesium. You can find the amount of HCl required for the 0.082 magnesium, 1:2 ratio. So 0.082, assuming that is completely react, divide by 1 multiplied by 2, molar ratio. 0.082 into 2, 0.164, 0.164 moles. You can get the idea now. If magnesium is a limiting reagent, to react all the magnesium with HCl, you need 0.164 moles of HCl, but actually you have 0.12. So actually HCl is the limiting reagent. So this is less than 0.12. Therefore we can say, therefore actually HCl is the limiting reagent. Therefore HCl is the limiting reagent, not magnesium. HCl is the limiting reagent. So once you find the HCl, always the reaction happens according to the molar ratio. So we can find, they are asking what is the volume of hydrogen produced at RTP. So we can easily find it using the formula. I'll do it over here. Therefore amount of hydrogen is half of HCl. HCl is, you have 0.12, 0.12 divided by 2 multiplied by 1, which is 0.06 moles. V equals 24,000 N or 24 N. So 24 into 0.06, 1.44 decimeter cube. That is the volume of hydrogen produced, right? So that is the volume of hydrogen produced, because even though the amount of magnesium is less, actually HCl is the limiting reagent, because 0.082, 0.12, but actually 0.12 is the limiting reagent, because we found it according to the molar ratio. So this is very commonly comes in past paper questions. We have to find the limiting reagent, and using the limiting reagent only we can do the calculation. So this is one common example that comes. So very common example, get the idea. So what you have to do is find the amount using the both data, data given for the both substance, then use the molar ratio to find the limiting reagent, then do the calculation according to the limiting reagent, right. So other than this calculation types, mass or molar mass or concentration volume, there is a very common example that you always get in past papers, that is using the gas volumes. So we will see how we can use the gas volume questions to do this limiting reagent. It is very easy one. Commonly you get this in the MCQs. So I will show you one, we will do one over here, and we will do one past paper question as well, right. So another question is like this, right. So very common past paper question type as well. We will do a past paper, but just before that, right. So this is a very common question. 100 cubic centimeter of CH4, that is methane, is reacted with, let us say, 400 cubic centimeter of oxygen. I am writing the simple way the question, carbon dioxide and H2O, carbon 1, hydrogen 4, so I have to put 2. So this is the reaction. The question is, right, what is the total gas volume at the end of the reaction. This is a very common question type that comes with the MCQs as well. 100 cubic centimeter of CH4 is reacted with 400 cubic centimeter of oxygen. They ask what is the total gas volume, right? The thing you have to understand in this question is the gas questions. We always assume gas volume is directly proportionate to the amount because V equals 24N. So we assume here V is similar to the amount. So in this case, you can assume that you have 100 moles of CH4 and it is mixed with 400 moles of oxygen. We can assume like that, and that gives the answer very easily. Right, so how to do this one? 100 and 400 is there, but according to the reaction 1 to 2, which means with 100 CH4 only 200 of oxygen react. So I can write this is initial. This is commonly come for the MCQs, but I have asked for the essay part as well. And reacted, what is the reacted then? With this 1 to 2, which means this 100, only 200 would react. Then remaining rim and formed, this 100 over 100 0, 400 over 200 you will get 200. The reaction is 1:1 for the carbon dioxide, so you will get another 100 cubic centimeter of carbon dioxide. Water at room temperature and pressure, we can assume it's a liquid. Therefore total volume is, you have 200 remaining oxygen and you have 100 carbon dioxide produced. Total volume would be 300 cubic centimeter, like that. It's very easy, but there is a way you use it. We assume volume is proportional to the amount, right? So we'll do one past paper question, something similar to this. So volume is proportional to the amount, that's what you have to remember, right? One last past paper question. The whole idea about the limiting reagent calculation is that, so here this is the question, I'll put it on the screen. Propane burns completely in oxygen as shown. The reaction is given. 100 cubic centimeter propane was mixed with 600 of oxygen. The mixture was ignited. The total volume of the gas mixture at the end of the reaction. So same as earlier one. So C3H8 plus oxygen. They have given the reaction. CO2 and H2O. So 3 CO2, 5 O2, 4 H2O. H2O is liquid state. So initial amount we can write 100 here. Here it is 600. Then reacted is how much? 1:5. So with this 100, 5 times 500 would react. Then remaining and formed 100 minus 100 0. 600 minus 500 you have 100 here. Then what about this? 1:3, you get 300 carbon dioxide form, so that 300 also comes over here, right? That 300 comes over here. Therefore total 100 plus 300, answer is 400. So answer is answer B. So that's how we do the limiting reagent calculation. Concentration, moles, volume wise, mass or molar wise, same idea. You have to find the data first, and then you have to use a molar ratio and again find the limiting reagent, and normally we do the calculation after that. So that's it, just a small video about how we can do the calculation based on limiting reagent. So when you do some past paper discussion, I will be doing it very soon, so you can get the idea how we can apply them in the past papers as well. Right, so if this is helpful, give us a thumbs up and consider subscribing. Thanks for watching.